Hello friends, welcome back to my YouTube channel MS Maths. In this video, we are going to discuss about the basic questions with explanation of the Z transformation. This is the part third, and in part 1 and 2, we have discussed the properties, basic formula, definitions, and all these things. To clear the concept and to know the concept of the Z transformation, you can watch that video. Now we'll continue in this video basic questions. Basically, basic questions like that. The main use of the Z transformation is nothing but like to solve a difference equation. In this video, we are going to discuss about the basic questions, like some exercise, like simple questions, and like that questions can be put in your objective types question. Like I'm going to discuss the question. Like first question is, find the Z transform of e to the power an. So like here I am writing the formula which is I am using in this which is using in the question. Okay, so on solving this question. So first of all, we have like these standard types of formula, but I'm just telling the what is the definition of the Z transformation. If un is a discrete sequence, then summation n equals to 0 to infinite un z power minus n. This z is an operator and this z is a complex variable. This z is an operator. Z operator. Okay. And this is the complex variable. Complex variables. Please note that and please defer that to writing this thing. Okay. So by using this, we have some standard formula. So z power an is nothing but z upon z minus a. It means I can write this thing like this: e power minus a power n. It means on comparing like this, a power n, like a is nothing but e to the power a. Okay. According to this thing, a is nothing but it is the z transform of this, and a is nothing but e power minus z. Then we know that z transform of an is equals to z upon z minus a, and z transform of e to the power minus an is nothing but z upon z minus e to the power minus a. And we can write like this ze, okay, z e to the power a upon e to the power a into z minus 1. So this is the answer for this question. Now come to the next question. Next question is says that like if you have a z transform like this a power n minus 1 on solving this question by using the same formula again. How? Can easily calculate. Okay. So I can write this thing is like a power n upon n. So it is nothing but a formula. Like it is a constant, 1 upon a is a constant. I can take outside, and z, it is nothing. Z operator. Z transform of a power n, and we know that the formula 1 upon a is nothing but z upon z minus a. So this is the answer. This is the simple thing, but there is a concept and there is a standard formula to solve easily like these types of question. Now come to the next question. Next question is here, like these are the standard formula or wait. Okay, now first of all, here solving this z transform of 1 upon n into n plus 1. First of all, we have to partial fraction like this: 1 upon n plus 1 is equals to a upon n plus b upon n plus 1. And now putting a equal, like I can write 1 is equals to a into n plus 1 and plus b into n. Now putting n equals 0 here, so basically we can get a equals 1, and similarly n equals minus 1 here, then b equals minus 1. Okay, like this. So it is nothing but that transform of a by n. So 1 upon n minus 1 upon n minus 1. And by using linear property, by using linearity property of the Z transform says that if you have a Z, if you want to calculate the Z transform of two function Fn plus Gn, you can write Z transform of Fn plus Z transform of Gn. So basically I can write it is nothing but Z transform of 1 upon n minus Z transform of 1 upon n minus 1. And we have the standard formula. This it is nothing but log of Z over Z minus 1 minus, and it is nothing but a Z, complex Z variable, Z into log of Z minus Z upon Z minus 1. And similarly, I can, if you want to put it in power, I can take common log Z. It is nothing but 1 minus Z log Z over Z minus 1, and I can write it is nothing but log of Z over Z minus 1 power 1 minus Z is in a power 1 Z. Okay, so this can be the answer for this question. Okay, now this is the answer basically. This can also the answer in like most generally this is the answer. Okay, by like by the property of logarithm we can put it in a power. Now come to the next question. Next question is here, and it is the okay. So we are going to using a property that is known as a damping property. It is nothing but a damping property. Like if you have a function fn and an is in a multiply, then in the z transformation of that function, you have to put a in a divide of all the z. Like first of all, this is nothing but z transformation. I am calculating this and tutorial. So it is nothing but a form of z transform of an into 1 upon n factorial. Okay, now z transform of 1 upon n factorial is nothing but e to the power 1 by z to the power 1 by z, and by using the damping, by using the damping property, by using the damping property of the z transformation, it is nothing but z transform of an is a multiplication in a fn, then it is nothing but z over n. You have to divide a in all z. And here z transform of an upon n factorial, it is nothing but this is the z transformation of 1 upon n factorial, and it is e to the power 1 upon z by a, and it is nothing but e to the power a upon z. So this will be the answer for this question. Now come to the next question. Is a like this. So first of all, by using the linearity property, z 3n minus 2 sin n pi by 4. Here, by using the linearity property, I have discussed linearity property like this. 3 is a constant, then z transform of n is minus 2 is a constant, z transform of the sine n pi by 4. Now here you can just write like the z power, if you have like there is a general formula, if you have n power p, if there is n square, then how can we write it? Like there is a standard formula, you can easily learn that formula, but like there is a general term minus z d by dz of z power x power p minus 1. This is the z transformation of a power x power n power p minus 1, n power p minus 1. Like if n is here, n is means like power, zn is z upon z minus 1 whole square. But how? Like zn is nothing but minus z. Okay, I'm just writing here. So zn is equals to minus z, and d by dz z transform of 1, and z transform of 1 is nothing but d by dz. It is 1 upon z minus 1. So basically it is minus z, and it is minus 1 upon z minus 1 whole square. So it is nothing but z upon z minus 1 whole square. So by this manner, we can easily calculate this types of, like, any power, for any power, like n power 2, 2 minus 1 is n. We have this value, and we will like differentiate this value again by u into v. Now come to the question. 3z, it is nothing but z upon z minus 1 whole square minus 2 z transform sine. There is nothing but 2, sorry, no, z sine x, and here is x is nothing but n. Okay, so it is the z sine pi by 4 upon z square minus 2z cos of pi by 4 plus 1. So we can simplify this term. You can simplify further. Okay, like 2, the value of this is nothing but z upon root 2. It is the z square minus root 2 z cos of pi by 4 is nothing but 1 upon root 2, and by cancelling 1 upon root 2 is by this 2 plus 1. Okay, and further you can simplify this thing is here from here, like it is nothing but z square plus 2z minus 2z plus 1, and by solving this, so I am leaving here basically. So by using the linearity property, by using the some important like standard function, we can easily calculate all the types of questions. So I hope you're getting all the concepts of these basic questions. For watching my video, keep watching MS Maths, and is such types of video you can subscribe our channel, and please support the channel, share the videos, and like the video. Thank you. Bye bye.